what collecting like terms is, right? Yeah, you don't need to go through it. Anyone want to tell me? Nick?
Is collecting like terms is when you get all the things that are like matching, basically.
Yeah, and how do you know if something's matching?
When they have like the same, they follow the same pattern.
Like, so
Yeah,
they have the same variable. Good, perfect vocabulary as well. So they have the same variables and the same degree and that kind of thing. So we did a Kahoot yesterday as well, just checking up on those things. What is part of an expression called when it's separated by a plus or a minus? So these are expressions at the moment, but for instance, we can have this and this. These are examples of two what? Just checking vocab. No. Begins with T. Terms. Good. Alright? So we've got terms, we've got more than one term, right? And do you remember what this 8 is called? We did this, like, so guys. Coefficients, good. We were doing repeat, so the ones with me yesterday will know this, should know, we repeated and repeated and repeated. Girls beat boys.
We don't talk about it.
We don't talk about it, no. So this is a coefficient, because it tells you how many ends there are. This, though, is called a
Constant.
a constant. Well done. Boys run it today. You know, they're not. So we've got coefficients. This is the coefficient of n. This is a constant term. Why is it constant? Because it has no variable. Good stuff. Okay. So we're just going to learn how to deal with these. So we're going to expand our knowledge to expanding brackets. Okay. Now I do want to take you back to something that you've just been doing before we look at those examples, which is, all right, if I say, think of, you don't have to write this down by the way, think of a number, we would write n, yeah, or any letter, yeah, any letter. And then if I said add 3 to that number, again, you don't need to write this down, what would you write? No. Add 3, so it's n plus 3. Good. Now this is the important line that I want to look at today, which is multiply your answer by 4. Alright, 3. Multiply your answer by 3. Now, we've done this in a very particular way, which I've actually been really impressed with, because you never made a mistake with this. So if I said, take this answer and multiply it by 3, you know it's
3n plus 9.
well done. Why is it 3n plus 9?
Because you can't just multiply the 3, you have to do both.
Yeah.
And if it's n, that means it also means that it's 1n. Like if you have 2n, but you don't write 1n, so it's n. So n times 3 is 3n.
Yep. Got it. Julianne, you can add anything?
Well, it's also called a degree. The n has 1.
Oh, the degree of n is 1.
So
Okay. But to explain the multiplying, I like what Paige just said, which is if I multiply your answer, I get 3 lots of all of this, right? So as Andrew correctly said, I've got 3 n's and I've got 3 3's. So 3 n's we write as 3 n's. 3 3's we may write as 9. Do you desperately need to? Because I'm in the middle of explaining something for you. Just till I finish. All right. Now I'm going to get you to write this in a sec, but I'm going to write it in a slightly different way. Which instead of writing this, I'm going to write 3 n plus 3. ideas why I've done that? Go for it.
I was gonna say the brackets usually you have to do that first.
And did we do that bit first? Yeah? So this 3 means I have to have 3 of all of this. Julia, what were you going to say?
I was gonna say, the 3 by the brackets also means
It does, yeah.
and
Multiply. And when you say multiply, it means I've got 3 lots of it. So just to summarise that, we know that 3n plus 3 is the same thing as 3n's plus 9. Can I get you to write that down? All of that. So this one, let's take 2x, 2 lots of x minus 12. Alright, so if we think about what's been done, alright, we have thought of a number, we've subtracted 12, and then we have doubled it. But I am now going to expand the brackets and put it in the way that we have normally been doing. Alright? So expand the brackets means get rid of the brackets, write it in the other way. So does anyone know how to do this one already? So write it without brackets. No ideas?
2n
So we've got 2n's minus 24. Now one way to show this is to say we have 2 lots of n, and we also have 2 lots of negative 12. Okay? Now that's quite an important bit, right? So this was the 2 times n, and this is the 2 times negative 12. That's actually quite important. Now, this kind of fireworks thing we call it is just showing you what I've done. So I've done the 2 to the n, I've done the 2 to the negative 12. Okay? Right. That makes sense? Okay. Let's get the next example, which is 5 lots of 9a minus 6b. 5 lots of 9a's minus 6b's. Okay. Any ideas? This is probably it's a more complicated one, because if I was going to read this as a trick, I'd be like, I've got 2 numbers there, haven't I? So we're progressing a little bit. It's a bit whatever. But
45a minus
30, yeah.
awesome. The reason is we've already got 9a's, so we have 5 lots of 9a gives us 45a's, and then we've got 5 lots of
6b.
negative 6b. Now the reason why I'm kind of being a bit picky with the negative like this is because that's where a lot of mistakes happen in one of the next examples. But how do you feel about that one? Yeah? Everyone? Swansea, you good for that one? That was such an important one. So just to recap for the video, negative multiplied by a negative gives you a positive, negative multiplied by the positive gives you the negative. Right, we have to do the same trick again. Last 2. So can you write D down? Don't write both of them, just write D because we'll have some space. First off, I'm going to deal with the brackets. Alright? Because the 6 is here and the brackets are only around this bit here. So the 6 is not multiplying any of those ones. Okay? So what would be my first step? Well,
Multiply 6 by 2n.
yeah, good. So 6 times 2n gives me 12 n's, and 6 multiplied by the 3 gives me,
15.
so it's plus 18. So that's 6 lots of 2n is definitely 12n, and 6 lots of 3 is definitely 18. The brackets have been expanded already, so now I just need to write my plus 8n and minus 1. So just to make it clear, I don't know whether you've got highlighters or anything, but this bit here has become that bit there. Alright? This bit's still the same. Alright. Now, the question is, can we collect like terms this time? Are there any like terms?
Yes. 8 and 12.
So yeah, we've got the 12n,
And 1 and 2.
and we've got a plus 8n, and then we've also got an 18 and a...
1.
So just because I've always done this with you, I'm going to rewrite it. Remember, the signs go with the term afterwards. So I've got 12n's plus 8n's plus 18 minus 1. So I've collected them together, and now I'm going to simplify. So my 12n's plus 8n's makes 20 n's. I'm at positive 18, but I subtract 1. Positive or negative?
70. It's positive.
We need the sign, so it's plus 17 because it's still positive 17. And there we go. That's our final answer. So if I want to, I can put it back up here. 20 n's plus 17. How do you feel about that one? Yeah? Alright. Now we do one final one. Now this one, most people get the first part correct. So we're gonna expand that. What does it become? 4k's minus 24. Okay? Alright. Now, Bonnet?
Do we part the back bracket?
The second one? So what would you do next? What do you think you'd do? So I think it sounds like a good idea to multiply. Just multiply by what?
4.
Oh, so you think this 4 also applies to this bracket?
No.
No.
You do it by itself. You might-
Because it's been separated by this. It's a different term. at the
What
moment.
different thing?
So this 4 only tells us I have 4 lots of k minus 6. So this 4 does not apply to this. How many of these brackets do I have? 1. Good. Not a lot of people get that right. There's 1 of them. How do I know there's 1 of them? There's a bracket and there's no number in front. But there is something that does make us have to think. And I always say this to my students. As soon as you see a negative sign in the middle, take a second look. Rethink it, just check. And the reason is, this negative is like having a negative, like you just said, negative 1 times. Okay? So we did 4 times k and 4 times negative 6. Now what we're going to do is negative 1 times 10 and negative 1 times negative 2k. So we get negative 1 times 10 is
9. Positive 9.
Negative
negative times what?
Negative
10.
Yeah.
So I'm just going to write negative 10. So I've got to subtract 10, but it's really just my negative 10. Then I'm going to, which is the bit a lot of people forget, negative, yeah, there you go. Negative times negative 2k is actually plus 2k. Did you write it quickly with a negative? Yeah?
Yeah, and then
Quite often people get the negative 10 bit and then just write minus 2k at the end. Okay, so just to, so we've got our notes. So this is 4 times k. This is 4 times negative 6. This is negative 1 times 10. And this is negative 1 times negative 2k. Now don't forget that when we did the question, that this 1 wasn't there. Alright? Now can we collect any like terms?
Yes.
What are they?
4K and
So we're going
2K.
to do 4k
And then
plus 2k. So,
and minus negative 24.
so minus 24 minus another 10. So 4k plus 2k. 6k. Negative 24 minus 10.
Oh yeah, no.
Pardon? Plus or minus? Good. It's minus 34.
That's what made my computer.
Got to take a moment every time you think you've got the answers. Oh, just take the second step. You know, this is one where, like I said, I could give it to my M5s and I know at least 1 or 2 of them would make a mistake. Not because they don't know, but because they would rush it through and just forget it. How do you feel about that one? Good challenging one, that one. Okay. Alright, over to you. What do you think?
No.
Give it.
Are you
So you
joking?
can see, like, this one is very similar to the one we've just done, right? This one is also the minus 2 times, so be careful. So this one here is pretty similar to just this one, but you've got twice, but this time it's a positive in the middle, which is a bit nicer. Alright. So, all we can ask you to do, look at the examples we've just done, try and apply it, do your best. Challenging material, definitely. You're definitely getting up to that level where it's gonna start looking really kind of difficult. But take it step by step. Like this one, for instance, like loads of it going on, and a minus in the middle. But it's actually there's no different maths. I'm going to record. So Nate just asked, could we collect like terms before we've expanded the brackets? I would say not, because, for instance, I've got 7x squared and 2x squared, but actually I've got 2 lots of 7x squared, and I've got negative 6 lots. So if I do collect the plus 2x squared with a positive 7x, after I've expanded the brackets, it actually becomes a negative. So if I collect them before expanding the brackets, I would end up with the wrong thing. Good question. So in all of these, we have to expand the brackets first.